In this tutorial, we will introduce the software application, PipelinesCAD, which is part of the Water Systems package. As a first step, we will click on the icon of Water and Sanitation Design in order to get the main menu for the package. We click on the button Execute PipelinesCAD to load the program. Initially, we will have the screen in where we should enter the topographic data of the project. This data will define the profile of the terrain. We have the option of enter the data manually, for which we have to write one by one the accumulated distance and the elevation of each station. Also, we can copy-paste data from another program like Excel using copy and paste. For example, I have this data in Excel, which I copy and paste in the program. To paste the data, I select the first cell, and by doing right-click, I will have access to the pop-up menu to paste. We will now see another way to enter data using the survey book format. For this, I also have in Excel a topographic notebook which I've ordered following the same format used in the program. Take note that we just need to copy and paste until the instrument height column, since the rest of the data is being calculated by the program for us. Like in the previous case, I'm going to copy and paste the project data. As we can see, the program handles the calculations for distance and elevations. Something that is important to note is that the format of the data must not use thousand separator, and the sign for decimal should be the decimal point. To finish entering the data, we have to write the name of the project and the design flow. I will use Project 1 to identify my project. And 1.7 liters per second as design flow. To see our profile, only click on Main Pipeline tab. Initially, we have a design that considers only the water source and the discharge, which may be the distribution tank. Note that the program gives us an alert of some sections with suction problems. To avoid this, we can place a brake pressure box at a high point near the section where we have suction. Something important provided by the program in the lower part of the screen is the project cost. This data will be very important to choose the most economical design. We will initially have 81,150 as a project cost. By placing a brake pressure box at this point, we see that the cost is slightly higher, but we have saved suction problems. Although the technical part has been resolved, probably we do not have an economical solution yet, so we move the box up by clicking the respective button and drag it to the point where I consider suitable. Although the cost has been reduced to a little more than 51,000, we still have suction problems in some sections. To leave the piezometric, let's increase the diameter in an initial section starting from the first brake pressure box. I'm going to force a diameter from this box up to 2,500 meters of accumulated distance whose data can be entered by clicking the Insert Diameter button. The diameter that I'm going to use is the immediate superior to 1.5 inches, which will be equal to 2.1. Click OK, and with this we have saved the suction problems. Between the source and the first brake pressure box, it is certainly that we do not have any suction problems. However, we do have problems with the high spot where we have dynamic pressures less than 1 bar or 10 meters of water column. At the bottom, the program provides the dynamic pressure to the point where the cursor is located. We know that when we have less than 1 bar pressure, we can have air dam problems due to the fact that this pressure is not able to break the vacuum. For safety reasons, I recommend using 15 meters of dynamic pressure so that at any high point where we have less of that pressure, place an air valve. For this section, I will leave the piezometric as I did in the last section, and I'm going to use a diameter of 2.5 inch, which is immediately superior to the design diameter of 2 inches. I will place this diameter from the source up to a distance of 500 meters. Click OK, and we see that the piezometric has been lifted enough to increase the dynamic pressure in several high points, beyond 15 meters. To put air valves, please click on the respective button, and by click again on the desired point, and air valves will be drawn. We must not forget that these valves must only be placed in high spots, where the dynamic pressure is less than or equal to 15 meters. Normally, the surveyor uses to indicate some sections where it will be necessary to place a specific type of pipes, such the case of rocky soil or bridges where it is specified that galvanized iron must be installed. In our example, suppose that we need to install galvanized iron from 1700 to 1800 stations. For which we click on the Insert Type of Pipes button and enter the specified distance. It is important to take note that for enter the type of pipe, only we must press the first letter key or G. Automatically obtain the type and the resistance to pressure of the pipe. After you click OK, we can notice that the program has forced the type of pipe in the 100 meters section. The program also allows us to place the cleaning valves, although for doing this we don't need a technical criterion rather than installing them in a low and accessible parts of the profile. It is important to highlight that placing these valves will serve as a reference for the drafter man. By clicking on the Spreadsheet tab, we will have the access to the project calculations. The program will provide for each section the distance, the inner and the nominal pipe diameter, resistance to the pressure, head loss due to friction, and coordinates for the terrain elevation and the pressure line, as well as the residual pressure at each station. At the end, we can notice that we have residual pressure of 3 meters in each discharge, which respond to a datum provided in the topographic data sheet. These 3 meters of residual pressure may be considered as a factor due to minor losses caused by fitting and curves, as well as any minor change made during the construction process. With this, we have finished the design. Now we just have to say print or export the project. To export it to Excel, we have to click on the respective button to obtain the dialog box. We enter the file name for which I'm going to use Project 1. After exporting to Excel, we have to search in my documents, Water Systems-PipelinesCAD-En project. Open the Excel file and we can see the spreadsheet will help us to prepare the drawings, print it out, or include it in our report. This is all for now. Thank you for your attention and until next time.